All right. Okay, let me start teaching again. So that was one example. Let's do another one. Example 3. Okay, so here in 1995, okay, so the cost of tuition at some college was this much. Now, even though you have per there, this is not a rate of change. Hopefully you can see that from the context of the problem. It's not a rate of change. But in 1995, that was the tuition cost. In 2000, we had this cost, $235 per credit hour. So what we want to know is the rate of change of the cost of tuition during this time span. So when I say it's not a rate of change, meaning it's not the one we're looking for. That's what I really should have said. Okay, so for this one, we want the rate of change, okay, of the cost of tuition during this time span. We'll notice really from the problem that our input, or I guess our independent variable here, would be time. Time, where 1995 is the starting year. 1995 is the starting year. Okay, so that's what our input would be. And our output, our dependent variable, that is, would be tuition cost. You know, it's depending on time. You know, in this year, the cost was this. In that year, the cost was that. Well, oh, what did I press? Oh, there we go. Okay. Thought I pressed the wrong button. But that's what happens here. So if we want to get the rate of change, right, it's basically like calculating a slope, right? So it's really just like calculate. So we're just calculating. If we take f of x to be our tuition cost per credit hour, right? That's what tuition cost is. X is how many years we have since 1995. That's what I decided to use. X was how many years since 1995. I mean, I guess if you did X, if you regarded X as the year 1995, I think that would work. You do have to be a little bit careful though. But either way, what you get is this. Rate of change, you would have the cost in the year 2000, which for me would be f of 5 years since 1995. That's $235 per credit hour, minus f of 0, which is the tuition cost in 1995, which is this. And then we divide by 5. That's the change in input, change in time. Right? F of 5 over 5 minus f of 0 over 0. So we get this here. Okay. And then when you do the calculation, you get 13. So that's the rate of change. Now, what does that mean? That means the tuition cost per credit hour is increasing at a rate of $13 per credit hour since the year 1995. And that's since the year 1995. Okay. So that's what's happening here. That's what's happening there. That's the rate of change. Now that we know the rate of change, we can then solve this part, write a formula for the cost of tuition, you know, as a function of the number of years since 1995. So I tell you actually to take your input as the number of years since 1995. Okay, so we have the rate of change, right? And we know it's a linear function because of the rate of change. So it has to be of the form mx plus b. Okay, so what do we have? Well, we have m as our rate, and f of 0 is time since 1995. That's what they imply over here, a function of the number of years since 1995, right? That's also how we got our rate of change. Well, in terms of those units. So we have m is 13, and b should be this thing. I don't know why the b is not there. But basically, we end up with this. You know, again, 13, that's our rate of change. That's what m is. And because our input is the number of years or time since 1995, 1995 would be regarded as time 0, or x when x is 0. And that's why b is 170. That's the initial value. So that's this example here. So hopefully this one wasn't too bad. I mean, this was sort of a word problem, but it wasn't as involved as some of the other ones we're going to see. But generally, when you have a word problem, there's some kind of strategy you want to use. I did post that strategy here. You know, you don't have to memorize this, of course, but it's good to know. You know, they have it in the book as well. I mean, it just gives you strategies that you can use for solving word problems. You know, for instance, we have this one where, well, for instance, the first step is kind of a duh, read the problem carefully. You know, of course you want to do that. You also want to make sure you can identify change in quantities, you know, things that are changing in there. You know, it could be time, money, whatever, because those are going to be variables. And of course, you're going to use variables to represent those quantities. You know, it's kind of like in the other problem where tuition costs, that would be a changing quantity. Time would be a changing quantity. So we use variables to represent that. Now the problem, the word problem also will generally give you important information like values of the variables. So, you know, you want to look for that. Not only that, you want to try and figure out what are they asking me to do? What are they asking me to solve? Do they want me to get the, I don't know, rate of change? Do they want me to get a formula? Do they want me to get, you know, how much money this person will have or an investment will be worth, that kind of thing. But either way, once you know that, step 3, you want to figure out a way to solve the problem. You know, there might be calculations, it might be forming a function, and then using that function to do this or that. You know, you want to somehow come up with a way to solve the problem. That's step 3. And 4, of course, you actually solve it. 5, as you can see, what you want to do is you want to reflect and check your answer. In other words, you want to see, does your answer make sense, not only calculation-wise, you know, mathematically, but also in the context of the problem. You know, I mean, if you're looking for, let's say, how much, you know, how long will it take for an investment to grow in value, you know, length of time, that is, it wouldn't make sense if your answer was negative. Length of time can't be negative. So in other words, again, you want to make sure your answer makes sense in the context of the problem. Good. And also step 6, make sure your answer is in the right units, that kind of thing. Okay. All right, anyways, oh, Schneike's wrong. I meant to go on to the next slide, not stop this, but since I stopped it, yeah, let me stop recording.